Okay guys, welcome. Before we can get to coding with OpenGL, it's important we understand what OpenGL is all about. And OpenGL is basically an open graphics library, which is a cross-platform, audio-accelerated, language-independent API for producing either 2D or 3D graphics. So it has that capability to do that. Now, when you're working with OpenGL, you must understand that it's basically there to interface to the graphics hardware of your computer system to somehow give your computer system more power to be able to handle those kind of graphical outputs. And it's composed of 3 libraries. And these libraries are the first one being the core OpenGL, which would consist of hundreds of commands which begin with prefix GL. So every function that you're going to come across that begins with GL, then understand that falls under the OpenGL. Now we have another one that we refer to as OpenGL Utility Library, or the GLU. Now the GLU commands will start with a prefix GLU, then follows with the purpose of that particular function. So every function that begins with GLU is based under OpenGL, that is OpenGL Utility Library. And the last one being the OpenGL Utilities, which is basically toolkits, and we refer to it as the GLUT. Now the GLUT command starts with prefix GLUT, and then follows the name of that particular function based on its purpose, of course. Now the naming convention that is used for these particular functions, here we have number one begins with lowercase. All functions begin with lowercase, just like in most programming languages. That's basically what we have. So it can either be GL, and then the name of the function, or GLU, the name of the function, GLUT, the name of the function. Now, this basically makes use of what referred to as the camel case. As you can see, in point number 2, we are saying followed by purpose of the function in camel case. Example, we have GL color. So the C of color must be in uppercase, then the others follow in lowercase, and that's basically what we're referring to as the camel case. Now the third one is followed by specifications for parameters. Example, we can have GL color, and then we have 3Fs. 3Fs, basically this talks of what we should see within the parentheses, or after the opening and closing brackets of that particular function are 3 floats must be there. If it is example GL vectex to I, then we are talking of 2 integer parameters there. So we're going to see these as we get into the coding. Now here is an example of how you can be able to define types. Now how do we define types? We have different types that are used just like in any other programming languages. We have integer, char, we have int, void, we have the signed char, we have short, we have the integer itself, we have float, and we have double. So there's a way that we need to be able to define them when it comes to OpenGL, and this definition is supported by gl.h. That header file will allow us to be able to define those types for us to use in programming. Now, when we are writing a program using OpenGL, there will be one-time initializations. There are some functions that you're going to write just once, and that is it. You do not have to write them again. Now, and most of these will fall under the main function, because see, we are writing OpenGL codes within the IDE for either C or C++. Now, we have initGL. The initGL is meant for carrying out one-time OpenGL initialization tasks, such as setting the clearing color. We have initGL, which is invoked once and only once, and you find it in the main function. Now within the main function, again, we can have a display function being invoked from this particular point where the function display is known as a callback event handler. So an event handler will provide the response to a particular event such as key press and all that. So the function display is meant to be a handler for that particular window paint event. We have the GLAD functions. As I've said, they are found within the main function, and we have GLIT or initialization. And this function will be defined, as you can see highlighted in blue there. It will basically have two parameters within. So the GLAD, also we have GLAD create window, which creates a window with given title. You can be able to give the title of a particular window as you run that, or as you execute that particular program. You can be able to run with a title on it. And where do you set that? You set that under the function, we call it GLAD create window. Again, we have GLAD init window size, where you specify the initial window in terms of the width and the heights, and this is done in pixels. So here we're working with basically pixels. So in this function that we are calling GLAD initialization window size will basically begin with the width, and then it will be the height, and you must specify them in integer type. Cannot be a float, cannot be a double. So you must enter integer value in that particular position. So the GLAD init window positions the top left corner of the window. That is the initial window at x, y. That is where we have the coordinate x and the y. So as you are giving them values, just understand that you're giving values. You begin with the one for the x coordinate and then the y coordinate, and then it will position itself on the screen based on the particular coordinates that you've given for x and y. And we do have the GLAD init or initialization window position. Again, it's also given in terms of the x and the y, so you must provide integer values for that. And we do have the GLAD display function. Now this one will register callback function or event handler for handling window paint, and this is where basically we're working with the display. When you have the void GLAD display function, and then you can give it some parameters there. So we have GLAD main loop enters the infinite event processing loop. That is, put the OpenGL graphic system to wait for an event to occur. So it will always keep on waiting for an event to occur. Should an event occur, then it is able to respond quickly based on the particular event that has been entered. And we find these under void main loop. So these are basically some functions that we're going to have under the main function, and once we set these functions, we may not need to make any changes to this particular function. As we write one program to another program and so on, you'll notice that most of the functions or most of the code that will come within the main function, we do not need to change it. Now, when it comes to color, because we'll be working with color, it's all about graphics, and graphics in most cases they come with color. And how do you work with color? We use the GL color function to set the foreground color, and we have GL clear color function to set the background color. Now these are basically the functions that we work with when we are working with color. We have GL color 3F, GL color 3FV, GL color 4F, GL color 4FV, GL color, clear color. So what you need to understand is that when you're talking of the what comes within the brackets is basically in format of the RGB, and that is the red, green, blue. Now when we add another value like the A, RGBA, here we are referring to as the alpha. The alpha, basically we are looking at the transparency. Okay, when you're looking at color from the perspective of transparency, is if you're able, we can be able to reduce the transparency of this color, and we can be able to see to change the color. That is, we are basically manipulating the intensity of this particular color. So you give a value for that particular manipulation, because like if you have RGB, and you've set R to be 0 and G to be 0 and then B to be 1. It means that that's will give us a blue color. Then you can also set now the intensity of that particular blue color using the L for alpha. In OpenGL, or when you're working with graphics, we are basically now working with geometric primitives, and we have geometric primitives that we do use to create objects such as trial, quad, line, segment, points, and they're basically given here. We have OpenGL will support the following primitives: that's GL line loop, GL line stripe, GL line point. We have polygons, we have triangles, and then we have the quad. So you basically work with all these for you to be able to come up with whichever kind of object that you're trying to draw using the graphics. And now we've been talking about the vertex itself. So vertex will basically be a geometric primitive that is defined by specifying its vertices, that is via the GL vertex function. That is, you give it an enclosing where you begin from GL begin and then GL end. So your code comes within the GL begin and the GL end. So anything that lies in between there will be used for defining the kind of primitive that you're going to be working with. And we have the GL begin specifies the type of geometric object, such as if it is a GL point, GL line, quad, triangle, or polygon. So within where we begin, where we have the GL begin, that's where we're going to be able to specify that. So don't worry, you're going to see it as we do the coding. Now let's look at this sample code here. When we're talking of GL begin, then within this GL begin, we can be able to specify that we're working with points. And what now comes next? These are the dimensions that we are given for the points that we are going to be working with. And you can notice that we're talking of GL vertex 2F, not 3F, 2F, meaning now we need two float values within those brackets. That is, we have an example here of negative 0.8, then we have 0.1, that is the X and the Y. So on the X-axis, we are going to negative 0.0, and then on the Y-axis, we are going to 0.1. Same applies to the other one. We are going negative 0.2 and then 0.1. Negative 0.2 on the X-axis and then 0.7 on the Y-axis. And then we do have negative 0.8 and then 0.7 on the Y-axis. So we've said all that must be within the GL begin and GL end. So anything that lies within that particular area, then that's what is specifying our points. So these points will be mapped on the screen based on the coordinates that have been given there. Now, when you're writing a program, we're going to, of course, to begin with #include GL, and then we have our glut given there because that's a directory, and in that directory we do have that header file specified there, GLUT. Now, and the GLUT would include the GLU.h, and then we have also GL.h. So we do not have to have an #include for those particular libraries or header files. They have already been defined within the GLUT, so we don't need that. Now we have our function here that we like using. This function, you can give it any name that you so wish, but in most cases we work with void display. Now the void display within that particular function, that's now where we begin to give the parameters of our geometric primitives that we are working with. Now we're working with points. Now, as we have said in the previous slide, we have 2F specifying the two floats that we need to give the coordinates of different points that we are talking of. Now, these are the 4 points. If we have GL vertex 2F and then another GL vertex 2F, there are 4 of them. So that implies that these are 4 points. And then we end it and then we flash it there to cause it to be displayed. Now, in the main function, now remember in C and C++ programs, what happens is that execution begins from main, and execution basically begins where we have the main function here, and then we have the initialization of the gluts, and then we would have the GL create window working with points. This one will give us the title of this particular window that we're going to be creating. Then on the next one, where we have GL init window size, we can be able now to specify the width and the height of our window that we want our object to be displayed on. And we can also be able to dictate where on the screen would want this particular window to be displayed. And then of course now we can do our callback. Now we have display here. Display is the function that we have just seen on the previous slide, and then we can enter into an infinite looping, waiting for any action that requires to be executed. And then of course we return 0. So since execution begins from the main function, and what I was saying is that in this particular main function, as we have set it as such, we might no longer need to change anything here. Maybe the only thing you can come and change is the title of the window if you change to something else, because here we're saying we're working with points. When it comes to working with the lines, you can come and change from working with lines to working with points. That is all I think you might be able to do. Everything else should be able to fit every other primitive that we'll be working with. Now, since execution begins here, and once we get to where we have glut display function, we are calling this function. Where is this function? It's this particular function here, and then now we can begin and then we can end there, and we can define we're working with points, and then these are the points, these are the coordinates, and they will be mapped on the screen. And once mapped on the screen, this is basically what we are going to see. This is the output that we are getting. There is one point there, another point there, another one there, another one there. I hope you can see the points. They are the white dots that you can see on the black section of the screen that you're seeing here. Yeah. Now, what about working with primitive lines? We're going to write that code, don't worry. So what about working with primitive lines? Now, working with primitive lines, we build on GL lines by allowing you to specify list of vertices through which a line is drawn. So when you specify GL line strip, a line is drawn from one vertex to the next in a continuous segment. That is, if we were to go back here, if we need a line to be drawn from this point to this other point, then that's what we are saying. We'll be working with GL strip, and that will allow the line to be drawn. Now, let's make again the use of what? Use of the same coordinates that we are working with when we are displaying the points. Here is the main function. As I've said, the main function, we might not need to change anything. The only thing we can change is maybe the title. And here the title has changed. It's creating lines. That is the only thing that has changed here. Now, here is the display function. And what changes in the display function is we are no longer working with points, we are working with lines, GL lines. And then these are the same coordinates we had from the previous program, and that allows us to be able to display the points on the screen. And I also need to mention that this line is also in the previous code. If you want it to work, if you are running it on a Windows-based system, then you need this line. So that's another thing that you must be able to note for your program to be able to work. So once we run that, then this is what we're going to get. The lines have been drawn because we have specified GL lines. Now, since we have specified GL lines, they are picked from this point to this other point, from this other point to this other point. And that is the reason why we have this kind of output that you're seeing here on the screen. Now, what about the line strip? Now, again, let's begin from the main function. Again, from the main function, nothing changes except the title. line strip. That's basically all that we are changing. Everything else remain as it is. So once this display function has been called, what happens now? We begin again, but we change what is within these brackets. It's GL, it's no longer GL line as we have seen in the previous slide, it's GL line strip. We want it to be able to connect all those points. We are still making use of the same coordinates because we want to be able to get a clear picture of what's happening when we change to GL line stripe. So let's see what kind of output are we going to get. This is the kind of output that you're going to get. So now you can see something else has changed, something has happened. We have added another line from this point to these other points. You have joined those two vertices. Now, I know you're wondering, how can we then be able to get a complete square or a complete rectangle? We can only be able to get that if we use what we are now referring to as GL line loop. Now, we are still working with the same coordinates. These are the initial 4 points that we are working with at the beginning when we showed the points. So if we change this to GL line loop, what kind of output are we going to get? Remember, main function, everything remains as it is except for the title of the window. And this is what we're going to get. This is the kind of output that you're going to get because we are now giving it the command to loop. And as it loops, it joins all those 4 points together to be able to get the shape that you are seeing. Now, working with lines. When you're working with lines, we basically maybe want to format the line. And if we're going to format a line, we can change its width and much more we can do. There's a lot we can do when it comes to formatting lines. So here the assumption is that the main function does not change except maybe you changing the title of that particular window to GL lines or formatting with formatting lines or whatever that works for you. So we have 2 points here. We have the -0.8 and then the 0.1, we have -0.2 and then the 0.1. So these are 2 lines. For you to be able to form a line, you need a connection from one point to another point. That's what forms a line. So working with one of these coordinates will not work. We need 2 to join them and form a line. And now the assumption here is that the main function remains as it is. Perhaps maybe you can change the title to whatever suits you. So once we execute, we get normal line. This is just an ordinary line. These are the 2 points. You join one point to another point and then you get the line. So we can manipulate these by introduction of the GL line width. So we can set a value for this particular width. In our example, we set value number 5, give it the integer 5, and then let's see the result if you introduce this one single statement there. And this is the output. Now you can see the line has changed, the width has increased. So based on the size of the width that you like to work with, that's basically what you're going to have to make changes of. Now again, we can also manipulate this line further, and we can manipulate this line by introducing GL line stipple. We can manipulate this line using the GL line stipple. Now GL line stipple allows you to be able to have 2 parameters here. We have 1 and then we have another value here. Now we begin by GL enable GL line stipple. So we need to be able to enable that. Once we have enabled that, we can still maintain the line, the formatting of width 5, and then now we can be able to work with our GL stipple. So we are basically defining a pattern for this particular line, and we are saying this is basically a comment and it won't be executed, but we are saying we are hoping to get a dashed line there. So same coordinates for the 2 points that form our line, and what do we get? This is the kind of output that we are going to get from that. Now, before we go any further, it's important for us now to run this particular code. So let's look at this code.